Do it. Yep. Normally it makes a noise. Hey, everybody. It's April 25th, 2022. This is the spring 2022 semester at College of the Sequoias. And this is Introduction to Statistics. And today we are starting chapter 12. We're almost done. There's a couple sections left we're covering. Chapter 12 and on, we'll be looking at 12 and 13. They are on 3 populations or more. So we did chapter 10 was 1 population. We did proportions. We did means. Chapter 11 was on 2 populations, and we did the 2 proportion, like a difference test. We did the 2 means paired test, where the data had to be dependent and paired up. And then we did the 2 mean test that was for independent samples. Today we're going to start looking at 3 or more populations, and 12.1 is on what is called the goodness of fit test. Okay, let's just put where it is at. You can see the directory for here right now. We are going to be going to stats, goodness of fit. And that says chi-square test. This is like phonetically like chi or like bi, but with a K, hard K sound, chi. Chi-square test for independence. And the symbol that goes with chi-square is, it looks like a kind of crazy X, and we got a square on it. So chi is a letter, I believe it's Greek letter. And move that over to the other side. There we go. And in the chi-square test, or in the goodness of fit test, that's what I want to call it, the goodness of fit test. What we have is, this is the 3 plus, or which is 3 or more. That's my shorthand from now on for 3 plus, or 3 or more is going to be 3 plus. 3 plus proportions test. That's our goodness of fit. And you might be asking yourself, why on earth do we call it the goodness of fit test? Well, what we have is, so we've got each group has an associated proportion. That is held to be true. This is like our H naught, as we'll see in a second. And what we do is we go and we collect data. So collect data. And what we want to do is collect data and test the claim that the proportions are what they say they are. Okay. So we'll get like a bunch of, we'll do a sample, go out and ask a bunch of, well, ask or survey, sample, whatever the case may be, collect the data, and then what we commonly are, well, let me finish this train of thought. So collect data and test the claim that the proportions are correct. And another way of reading how that says is like, how well does the data fit the expectations? What we expect to be true. And there's our fit. How well is another way of saying good. So goodness of fit. Oftentimes we will either have, we often have the target proportions. So we usually have, well, not target proportions. We usually have the proportions we're aiming at. Know those proportions. And when we collect the data, we don't have proportions. I mean, we could calculate it, but we don't have them in the beginning. But the collected data does gives us a sample size. So rather than comparing proportions of the two groups, because then you start looking at decimals and everything's really small. So rather than comparing proportions, which is small numbers, we compare values. Values are frequencies. And so we don't have, our data, we can do a frequency. We can count up how much each time response was given, and we'll go from there. So our observed frequencies are easy to get. Observed data leads to our observed frequencies, which is just the total per group, which is what I just got done saying. Our expected values, though, we don't have those. We have proportions. So to get expected frequencies, we have to do a little bit of multiplying. And we've done this a lot. You've had a proportion, and they said if we had 1,000 people, what percent or how many of them can we expect to say a certain thing? We've seen this a lot. What you had to do each time was you had to take the sample size and multiply by the proportion. And we'll do this for each group. And that sounds like a lot of mumbo jumbo, but we will do an example very shortly. In fact, before I go into all the requirements, we will go into an example first. How's that sound? Let's get to the meat and potatoes. Let's see how it works, and then we can look at the requirements for it. So I'll leave that up a little bit longer, let you write down what you need to. Got my ceiling fan on here. This is the one room in my house that's warmer than everywhere else, and it's starting to cause it to blow. Any questions so far? Okay, if you need that up longer, let me know. First, we're going to write down the problem. And this is a problem most of you have seen at some point in your life, maybe never thought of as a problem, but maybe you did. Maybe you've wondered this very question. M&Ms come in 6 colors. What proportion of each bag is each color? Or rather, what is the expected proportion for each bag? So this is actually something Mars produces. The Mars company. So Mars company produces M&Ms. In 2 different facilities. Which oddly enough, each have their own proportion. The proportion for each color is different in each facility, but I'll actually write that where the proportions in each facility are different. Are different. But they claim the following proportions overall. So let's just make a little table. We got color and we got proportion. So what colors do we got? We got brown and yellow. We've got red and blue. They didn't do red for blue, one of those for a long time. Blue, they didn't have blue for a long time because the blue food coloring or something like that was tied with cancer, something that's changed. Maybe it's a new food coloring source now or something, but it's no longer a problem. And they brought blue back. And then they got green. Everybody knows green. She used to wear the high heels. Now she's got the librarian sneakers. It was a great mock thing in the news in the last 6 months. Tucker Carlson on Fox News kept going on and on about how they took the sexiness out of the green M&M. It's like, I don't know. Did anyone ever look at the green M&M and go, hubba, hubba, that chick is hot? I hope not. But maybe you are into chocolate characters. If so, well, green did look pretty good. She's cute. But the target proportions, 13% was brown. That was actually the same proportion for red. Yellow was a little bit higher at 14. Blue came in at the top, 24. And I think that's because blue got left out for so long and they brought him back, made him the boss, or not the boss, but brought more of them. Before blue, orange was like the newest one to have a character. He's the crispy M&M. He's at 20%. And our leading M&M lady, green, comes in at 16%. So those are the proportions that are claimed by the Mars company for M&Ms. And while you're writing it down, let's see if I can find the information where it shows the other ones. Where are M&Ms produced? Hello. Really? No one cares who's behind the scene. Okay, that didn't give us the information I wanted. Well, maybe Wikipedia. Let's go with Wikipedia. Let's see. Find the percent sign. Shit, it doesn't have it in there. I know if I had it somewhere. Let's see. Wow, shaved student's head because he fell asleep in class. That's got to be a fun read. I'll come back to that later. I should have had it ready. So let's do an example. Who we got in chat today? Jorge, you like M&Ms? Are you a chocolate eater? I have to ask. Some people don't like chocolate. I know.
Yeah, I
it
sometimes eat
seems
them now and then.
like evil to me to not like chocolate, but hey, some people don't.
Yeah,
Jorge, are you evil? Do you not like chocolate, or are you a chocolate eater?
Yeah, I'm kind of a chocolate eater. I eat it now and then. Oh, hold on. Hello, can you hear me?
Let's go with Gabe. Jorge may not be at his keyboard. Fuck it. We're using Gabe. So Gabe samples 600 M&Ms.
Mr. Jones, Jorge is talking. Can you not hear him?
And records his observations about.
Hello?
I don't think he can hear us.
Okay, you can hear me?
Yeah, I can hear you.
Okay, well, let's tell him in the
So
chat.
let me make another column here. Oh.
But yeah, just type in the chat. I was going to do that too.
So Gabe's observation. Gabe counted 83 brown M&Ms, 87 yellow, 70 red, 130 blue, 134 orange, and 96 green. Oh, do I have mute on? Oh, some bitch, I do have mute on. That is so my bad. I can hear you now. I can hear you.
Oh, there you go.
So are you guys evil? Do you guys not like chocolate?
I eat it now and then.
Okay, so we'll say Gabe and George do it together. Or not George, Jorge. Gabe and Jorge sample 600 M&Ms together and record their observations above. So Gabe and Jorge. My bad. I'm so used to you guys typing in chat. Then I don't know why I had mute on. That was terrible.
It's
okay. So how do we go about doing this? Well, to test it in StatCrunch, we need things that match, and we have observed numbers or frequency in one column. We have observed or expected proportions in another column. So what we're going to do is we're going to make a column for expected values. And since you guys ate 600 M&Ms, we're going to do our N times P is going to be 600 times the proportion. So if I do 600 times 0.13, I get 78. If I do 600 times 0.14, it's 84. The 78 I just calculated. 24, 600 times 24, or 0.24 is 144. 600 times 0.20 is 120. And 600 times 0.16 is actually 96. So in StatCrunch, we have two things that need to happen, or we have two possibilities. In StatCrunch, we have to, we must. A, enter the observed values in a column. And B is enter the expected values in a column, of course. Or if all the proportions are equal, P0, P1 equals P1 equals P2 equals all the way up to K, they all equal each other. There's a checkbox. We're going to do the checkbox for cells in equal proportion. Lay that down a little bit. It's trying to blow away. Give me time to write that down. I feel bad. I can't believe I had the mute on. That's terrible. I wonder if I bumped it. I don't turn it off for anything ever on this computer. So while you guys are doing that, I'm going to actually do this in StackHack. I'm going to start recording the information. So I've got my observed values. And I've got my expected. And maybe I'll put the color in here. That way I can, it's easier to track. Yellow, maybe I should put the color first. See if I can drag that over. How about I copy it over? Okay, my observed were 83, 87, 87, 70, 130, 134, and 96. And my expected values are 78, 84, 78 again, 144, 120, and 96. Okay. So we're going to do our test. We're going to do our hypothesis test, and maybe I should, this is why I usually give the information in the other order. We have to, what's the first thing we need for a hypothesis test? H naught and HA. So step one is identify H naught and HA. And I alluded to it earlier with what I wrote. For the goodness of fit test, H naught is all values or all proportions match up with their expectations. And then HA is at least one proportion is different. So that is every goodness of fit test. Specific to our M&Ms. For our M&M count, the color proportions of M&Ms match what is reported by the Mars company. And H8, at least one color doesn't match. M&M's does not have the expected distribution proportion. Okay. All right, that's step one. Step 2 and 3, we can kind of do together. We need alpha. We need our test stat. And we need our p-value. I didn't give you an alpha, so we are going to go with 0.05. And for this, we're going to do stats, goodness of fit, chi-square. So I'm going to show you all cells in equal proportion first, even though that's not the case here. Our observed value, I actually marked with observed, made it easy to find. They want you to tell it where the expected values are. If they're all supposed to be equal, like you're rolling a dice or something like that, where every side should have the same outcome, you're going to click all cells in equal proportion. Now I'm going to show you what that looks like here with M&Ms. If we think about it, there was 600 M&Ms that we chose, and there were 6 colors. If they're in equal proportion, 6 colors is like 6 sides of a die. Each one should be 1/6, which means expected values should show up as 100. And they do. So if they were expected values, each color would be 1/6, which it's not. Or if they were all in equal proportion, each color would be 1/6, and we'd get 100. But we don't. We have actually recorded data. So put that back to observe, and we click on expected and say it's in the expected column. We click compute, and it gives us our values. Gives us my chi-square. This is the symbol for chi. I think I said that earlier. We'll put 4.24. And my p-value is 0.515. So step 4 is come up with make a decision. Which means we compare alpha and p-value. 0.05. Oh, I normally put p-value before alpha. I'm going to do that. 0.05 and 0.515. The 0.515 is larger, which means, so if it's smaller, we reject. So it's not smaller, we don't reject. Do not reject H0. Do not support HA. And this means not enough evidence to support HA. The three nots go together. Not. Do not reject H0. Do not support HA. There is not enough evidence. So that will be my conclusion. HA was that the colors are different. There is not enough evidence to dispute the Mars Company claim. About the M&M distribution proportions. Let's see if I can make this happen. Let's see if I can make it do it. So what do I gotta have happen here? I need maybe, let me make this a 99. And let's lower this down to 99. Let's see, I've got, I think that's 600 still. Maybe I'll make this 95 and this 89. That way I don't have two 99s. I'm trying to see if I can make it so it does break it. So if I reevaluate this, let's say we did a new sampling and we had this. There we go. The p-value is quite a bit different now. So if this is the circumstance and we have one where here we could say at least one color is different, you might at this point, if you were doing some research, you might want to know which one. You kind of want to go in and do like do a proportions test based on either, like in this case, like all of them are above their colors by a little bit, but orange is a lot below its number. So I would say maybe orange is the one that's off. So I'm going to test that one. I'm going to say orange is, I'll test the orange one. And I would go to our proportions test for one sample. And I'd say with summary. And I say we had 99 successes out of 600. That's what I put it as. But the expected proportion for orange was 0.2. And I will say not equal to. I'll leave it at that. And I could click compute there and I could find out, oh, look, I was right. It is the orange one. The orange one's off. So it's below 0.05. It's the one that's screwing up. But the chi-square test, the goodness of fit test, doesn't really show you which one it is. It just says something doesn't match. Okay. But you can always turn it into like a binomial, well, not always. Often you can turn it into like this binomial example. Any questions so far? I will put this back the way we had it. What did we have? We had 83. Oh, wait. I wrote it down. Where's my piece of paper? I had 78 and 84. And this one was 120. Reanalyze. Now it goes back to being do not get rid of. Okay, so let's take a look at what our requirements are, and then we'll do another example. So what are the requirements for the Kite or the goodness of fit test? So our requirements are, one, all expected values must be greater than 1. Greater than or equal to 1. And we will have a second one. I'll list that. Well, we can. You only really need to list the second one way, but we could list it 2 ways. So one way of listing it is no more than 20% of the groups have an expected value below 5. Five is kind of like a borderline one. You kind of want more than 5. Another way to write this would be no more than 80%. Or not no more than, at least 80% have greater than 5 as the expected value. Things we need to make this calculation, we need the target proportions. We need the expected proportions. Or values. Usually it's proportions. And recall, to go from proportions to value, the expected value is n times p. We actually did this when we did roulette also. We've done n times p a lot this semester. Okay. To go on with this, I am going to actually go into our homework set, and I am going to do an interactive assignment, at least part of it. And so do one of the examples. So let's click on the interactive assignment. We're on 12.1. The reason why is I don't think I have enough questions in my homework chapters 12 and 13. So you should probably do these interactive assignments for 12.1, 2, and 3. I would change the homework for chapter 12 and 13 to actually add more. The reason why I said there's not enough is 10 for 3 different sections. That's only 3 or 4 problems per section. It's not really enough. But someone has already started it, so it will not let me edit the questions. So instead, we're going to look at an interactive lesson, and I recommend going into it because this will give you 6 problems to try out that are related to it. Some of these other previous ones are like old things, but the goodness of fit test, there's like 6 of them. So I will click on continue assignment because I was looking at it earlier. I'm going to jump to where some of the problems are. And I'm just going to skip forward till I get to example 3. Example 3 looked good. So this next part is this is 12.1 interactive lesson number 3. Example 3. And it's on inequality in distribution of income. Income distribution. So it says the data in table 2 represents the distribution of household income in 2000. An economist would like to know if income distributions are changing. So she randomly selects 1,500 households and obtains the household income. Table 3 contains the results of this survey. Does the evidence suggest that the distribution of income has changed since 2000 at the alpha equals 0.05 level of significance? So I'll just jot down what table 2 has. And I'll put the categories. There's a lot of categories here. And we've got less than 15,000. Rather than writing the thousands, I'm going to put K. I'll say 15K to 25K here. 25 to 35. 35 to 45. Nope, 35 to 50. They're not even groupings. Look at that. The size of the group changed. 50 to 75. 75 to 100. And now it gets bigger again. 100 to 150. 150 to 200. Or at least 200 means greater than 200. So let's see, I'll put a little line here for every 2 groups. That way it's easier to kind of like match up what we got here. I've got 10.2%, 9.8%, 9.9%, 13.3%, 18.1%, 13.1%, 14.6, 5.8, and 5.2. I'll write down my observed. 168, 144, 141, 194, 254, 184, 210, 99, and 106. All right, so I got my values up there. We're gonna copy those over. Maybe we'll get lucky. Is that upload? I don't know. I'm gonna hit Control C. It does. Sweet. Look at that. Bam. All right, so I have my expected value there. I don't know. I need to calculate this. But when I try to do the chi-square test, I don't have my observed values are percentages. I don't like that. No, my observed values are numbers. I do have those. But I don't have the expected value. So I'm just going to click all cells in equal. This is the lazy way of getting n. I'm going to do all cells in equal proportion just to, oh shit, I already know. Problem did say 1500. So 1500, that's what I need. I'm going to actually close this. And we're going to enter expected values after we calculate them. Which means I need to take each of those numbers and multiply by 1500. There's my calculator. 1500 times, and remember to convert the percentage to a decimal, 0.102. And that gives me 153. And then I will do 144 or 1500 times 9.8. So over here, this was 1500 times 0.102. I'm going to do 1500 times 0.198 or 0.98. That's off. And I know why it's off, because I didn't have a zero there. 0.98, there we go. 147. And I'm going to go down this list and do that. So I got 1500 times 0.099, which is 148.5. 194 times 0.133. What am I doing? 1500 times 0.133. 199.5. 0.181. And it takes some time, but we will get them all in there. Oh, I so did the wrong thing. Times 0.058. There we go. 87. And 1500 times 0.52. 0.052, I mean. 78. All right, so I've got my values here. I'm going to type them in. All right, I didn't add those up, but if I do my test in my stats, chi-square, or stats, goodness of fit, and then chi-square, kind of a fancy X when you do it. I'll find out if I typed it right, because my n should still equal 1500. My n still equals 1500, and let's see. So let's go through the test. You can see all the expected values on the screen. So I'm going to move this piece of paper. So our hypothesis test is step 1, identify H naught and HA. And the wording on the question says that these values were in 2000. And the question is, has the values changed since 2000? So H naught is the values haven't changed. And in this case, that means the percentages. And HA is at least one of them is different. One of the income groups does not match expected, or one of the income groups has changed. So this is a before and after kind of example. The M&Ms one we did was, this is the reported values, but we're testing to see if we actually do it. And if I were teaching this in class, I would give you all a bag of M&Ms and we would do this experiment live. Everyone would count their colors before eating them. And then you're welcome to tear into the M&Ms, and we would do it live. I would have no idea what the values are. We would conduct it live. But we have them here, so we're just going to use that. Let me go back over to my trusty stack crunch we got over here. My step 2 and step 3. Step 2, I think they said alpha equals 0.5, now that I think about it. They did. A equals 0.05. My p-value is 0.0415. And my test stat, which is the chi-square, equals 16.061705. So that's steps 2 and 3. Step 4 is compare and make a decision. So I will compare my p-value, which is 0.0415, with alpha, which is 0.05. And I see that my p-value is below it. So the p-val's too low, the null must go, or p-val's too low, reject the hoe. We reject H naught and support HA. And remember, the knots go together. This doesn't have any knots, so it is not enough information or not enough evidence. There must be enough evidence or sufficient evidence. So that's what my conclusion statement will be. There is sufficient evidence to support the claim that the income group percentages has changed. Since 2000. All right. So 12.1, 12.2, and 12.3, they all have different types of H knots. Notice I don't have a P listed anywhere, P or mu listed in my H knot. They're sentences. And that's kind of how like the other ones are going to go for 12.2 and what we do in chapter 13. So I recommend doing the interactive assignments for each of these sections first. So that you know what you're doing. You might be able to squeak by and get by with minimal understanding of it, but is that really helpful for you in the long term? There's a good chance that you will read research papers in the future or in your sociology class or in your job. And knowing how the stuff works is probably worth doing. So it's worth taking the time to do the interactive assignment. Remember, it's not graded. So just use it as a learning experience and you don't try to have to go for 100%. The only thing that is great is the actual homework assignment. Is there any questions? All right, I know your guys' semester is getting nearing an end, and I know you still got a project to do, and I'm sure I'm not the only teacher that gave you something big to do by the end of the semester. So we'll call it a wrap, give you time to work on it. We will have a lesson on Wednesday for 12.2. Next Monday, we'll be doing 13.1. That Wednesday, the project will be due in 2 Mondays from now, 2 weeks from now. So I recommend, I'm going to give you next Wednesday free to do work on your project and stuff like that. I will be in Zoom if you have any questions on any of it. Project, what we studied so far, that will not be this Wednesday, but the following Wednesday. This Wednesday, we're going to do 12.2. Other than that, I am done with this presentation. Have a good day. A good day to you, sir.
Have a good day, Professor Jones.
You too.
Thank you, Mr. Jones.
Thank you. Got this. Okay, you guys kept coming.